Math 3, Unit 10, Section H. Today we're talking about cosine. So yesterday we did sine, today we're doing cosine. A lot of this is similar, but it's going to have a different shaped graph, different zeros. So if you take out your unit circle, we will start by writing all these in, and then also if you have a calculator, or if you don't, you can grab one. We want to, again, do our fractional form and then our decimal form. Okay, and so starting with cosine of 0 on our graph, remember cosine's always dealing with our x, so in this case cosine of 0 will be 1. Very good. So 1 in both of these spots. Okay, pi over 6, our cosine value is good, root 3 over 2. And when we put that into our calculator, it equals 0.9. Good. So we have 0.9. Okay, pi over 4, the x value is root 2 over 2. And root 2 over 2 reduces to be, as a decimal,
0.7.
Very nice. Okay, pi over 3 is 1/2, and that one, tough decimal. Very good. Pi over 2, what's my x value at pi over 2? 0. And so I don't know if you remember the sine graphs, but remember on the sine graphs we started with 0 here and we had a 1 here. So you can kind of see how things are a little bit different. Also, if you're just looking here even at your unit circle, you can totally tell, you know, there's a difference. They'll have all the same numbers, but they're in different spots. Okay, so 2 pi over 3. What will be my x value here? Good, negative 1/2. And that's negative 0.5. 3 pi over 4 is good, and that's negative 0.7. 5 pi over 6 will be good, and that reduces to negative 0.9. And then at pi it's good, negative 1. And be careful of your negatives and positives, because that makes a big difference. I'm noticing on some of your quizzes that you guys took from Monday, you are forgetting the negatives, and so they're being marked wrong, so be careful. All right, so we're writing pi again here, which is negative 1 and negative 1. 7 pi over 6 is negative root 3 over 2, and that reduces to be good. 5 pi over 4 is negative root 2 over 2, which will be good, negative 0.7. 4 pi over 3 is good, negative 1/2, so negative 0.5. 3 pi over 2 is 0. 5 pi over 3 is 1/2, which is 0.5. 7 pi over 4 is good, which is 0.7. 11 pi over 6 is root 3 over 2, which is 0.9. And then 2 pi is 1. Okay, so any questions on filling this out? We're all okay with that? Okay, so now we're going to start plotting these points. Okay, so at 0, it is at 1. So this is different from yesterday because on the sine graph it started at 0. Okay, pi over 6, we're at 0.9. Pi over 4 is at 0.7. Pi over 3 is at 1/2. And I didn't quite make this, well, that'll be okay. Pi over 2 is 0. And then 2 pi over 3 is at negative 1/2. So notice how it's just going down. 3 pi over 4 is at negative 0.7. 5 pi over 6 is at negative 0.9. And then pi is at negative 1. Okay, and so then this, Okay, so then now we're going back over here. We already have the pi, and then negative root 3 over 2 is at negative 0.9, or sorry, 7 pi over 6 is at negative 0.9. So I'm just gonna start matching these ones now as I go up. 0.7 I have about right there. 4 pi over 3 is at 0.5. And then 3 pi over 2 is at 0, good. And then 5 pi over 3 is at 0.5. 7 pi over 4 is at our 0.7. 11 pi over 6 is 0.9. And then 2 pi is at 1. Okay, and so when we try to make our smooth curve to the best of our abilities. Okay, so this is still going to end up looking like a wave, but the cosine, it's more spread out, right? Okay, just like with sine, we're going to just have 5 major points that we want to look at. And again, they're going to be our 1s and our 0s. You'll notice on cosine that we only have 2 0 points. And we have 3 1 points. On sine, we had 3 zeros and 2 different 1s for each period. Okay, so let's go ahead and answer the questions down here now. Okay, so what is the highest y coordinate? Good, 1. And where is 1 located at? Good, 0 and 2 pi, good. And those ones do go above our 0 line, good. The lowest y coordinate was negative 1, and that one occurred at just pi. Okay, and since this function is periodic, which means it keeps going from period to period for infinity, what would be the domain? Very good. Negative infinity to positive infinity. And then what would the range be? Good, negative 1 to 1. And then why do we use brackets again? Good, because it equals that, right? And so if it didn't equal it, it would be a parenthesis, but since it equals that 1, it is a bracket. Okay, and at what locations is the value of the function equal to 0? Good, pi over 2 and 3 pi over 2. And then remember that your amplitude is always with the value that's in front of your function. And so in this case, we have if there's nothing there, there's really a 1 in front. So this amplitude for cosine is also 1. And so if the value in front changed, it would change the amplitude of our function. Okay, questions before we move on to the next page? Okay, so number 2. Okay, on this one we have y equals 1/2 cosine of x. And so what does that 1/2 tell us?
The amplitude is smaller.
Good, a smaller amplitude. The amplitude is going to be 1/2. So it's basically kind of going to shrink our graph, right? Or the width of it will change. Okay, so what we're going to do is go to the other side and we're going to multiply everything by 1/2 in order to move it. But we're just going to do our 5 major points. Okay, so if we go back here and we want to use another color, so if at 0 here, if we multiply it by 1/2, where will my point be?
0.5.
This will be at 0.5, right? So we're just going to go by 1/2. But at this point, this 0 will still be at 0. And this point down here at -1 will end up being at good, negative 0.5, and then this is at 0, and then my last one, instead of it being at 1, it'll also be at good. And so again, we're going to go ahead and try to draw our curve in a smooth function wave-like pattern. Mine does not look great, but there you go. Okay, so you can kind of see it almost looks like it's like smushed it a little bit. Okay, so going back to the other page to answer our questions. Okay, what would be our highest value? 0.5. So you can write 1/2 or 0.5. And at what locations does that occur? Very good. So 0 and then also 2 pi. Okay, and then the lowest value is, good, -1/2 or -0.5. And at what location does that occur? Very good. Pi is correct. Okay, since the function's periodic, what's my domain? Good. And on this one, what would be my range? Good. -1/2 to +1/2, or if you did 0.5, that also works. And then where are your zeros located? Good. So our zero is right there. Pi over 2 and 3 pi over 2. And then, oops, sorry. And then what is our amplitude? 1/2. Very good. Before we move to this graph and we start doing our shifting, let's just go back and look at this graph one more time. So, couple things is that our zeros are at different spots. So we have zeros, our starting point is pi over 2, okay, for my 0, and then also the other 0 here is at 3 pi over 2. So those are important things. And then this one, it is above, right? So it goes above 0 and then it goes below. Are we okay with how I'm writing this? So we start above, we go to 0, we go below, then we go back to 0, and then we were back above. So it's important to kind of remember what the sine and cosine functions look like when you are plotting these points. Okay, so what does, on number 3, what does the 3 represent in front? Good, amplitude. So that means that normally when we'd have 1, we would move it up 3 or down 3 from our 0 mark. Okay, and then this +1 here at the end, what does that mean? Very good. Up 1. Okay, and we already have some of this information here if we forget, but pi over 2, this is pi over 2, and this right here is 3 pi over 2. That is where my normal or my original zeros are, correct? Okay, so I like to put points here to remind myself what to do, and then I can go back and erase them, okay? And so the only thing I have to change in terms of my zeros is I have to take each of these and do what? So up 1, this is my new 0, and up 1, that is my new 0. Okay, so I'm going to go back and erase these. Okay, and so with the sine graph, and actually I'm going to end up making this in a color so we can see this better. Okay, so with my cosine graph, we start where? So remember, we're going to have points in between here, right?
Yeah, but you're going to start at 1.
Good, so we're starting here, and is it going to go above or below?
Above.
Above. And because it's 3 from my 0 point here, which is at 1, but it's my 0 line, my equilibrium, I'm going to go up how many?
3.
1, 2, 3. So we have a point at 4. Okay, and so this one then ends up going where? 3 down from here. Okay, so remember it went above to the 0 and then down. So we're going down 1, 2, 3, and I end up at -2. Good, and then at this point, where does it go?
It goes
Up again, and we're going to go up 1, 2, 3. Okay, and so remember, this isn't a parabola, so just be careful. It's going to end up kind of going like in a wave. Okay. So what's the highest value here on this function? 4. And it's at 4 where?
0 and 2.
Good, 0 and 2 pi. The lowest value is at -2, and that occurs at pi. And then it says using a different color, extend it. Okay, So from here, where would be my next point here?
It would be at 1.
Good. And then from there, you would keep going down, and at 3 pi, you'd have a point at -2. Okay, and then on the other side, my next point would be at 1, good, and then -pi would be at -2. So we're just repeating our pattern. Good? Okay, and what's the amplitude of this one?
3.
3. Very good. Okay, do we have any questions? We're good? Okay, number 4. So a couple things on this one. First of all, the negative means what? It's going to be reflected across our equilibrium, or if you want to, we could even put start below instead of starting above, right? So the negative just means that we're going to start below instead of starting above. Okay, what does the 2 in front mean? Good. Amplitude. And I personally feel that like writing out all this information is helpful, because when I look at it here, sometimes that doesn't really make sense to me, but when I write it out in words, I make sure that I actually do it and it makes more sense. Anything that's in parentheses, what do we do? Right or left. And so in this case, because anything that's in parentheses, it becomes the opposite, I'm going to end up going what? Good. Right pi over 2. Okay, any questions about that? Okay, so I always like to start at where my zeros should be. And so I'm going to relabel this pi over 2 and my 3 pi over 2. Okay, and so normally my zeros are at pi over 2 and 3 pi over 2. But in this case, we're going to go where? To the right. And so we're going to go from here, we're going to go right pi over 2, so that's just one of these marks. And then this one also, we go right pi over 2 by 1 mark. And then I'm going to go back and erase my original markings. And that did not work out good. Okay. So far, so good? Okay, so we go here, and normally we would be at a +1, correct? But because of the negative, we would need to go down. But because the amplitude of 2, we're going to go down -2. Okay, so at 3 pi over 2, then we're going to go where? Up 2. And then this next one is actually 5 pi over 2. We're going to go where? Down 2. Okay, and then hopefully we can draw our smooth curve. Okay, what's the highest value? 2. At what location does it occur? Good. What's the lowest value? -2. At what location does it occur? Good. Pi over 2, 5 pi over 2. And then we're going to extend the function. So at 3 pi, where am I going to be?
That would be at the 0.
0. Okay, and then at 0 over here, we're going to be where? 0. And then we're going to go where? Up to 2, and then we're going to go back to 0. Okay, and what's the amplitude? 2. Okay, any questions about anything that we've talked about today?